So we're going to go over polyatomic nomenclature. And polyatomic just means many atoms. And it just so happens that there are some groupings of many atoms that will combine to make something that deserves its own name. And so there are a number of polyatomic ions, and all chemistry students have to go through some bit of memorization of them. I've given you a much longer list, and this is a very short list over here. But just to go through some of them, there are cations. There's a couple that are common for us. And one of them is ammonium. Its name is ammonium. Its formula is NH4, and its charge is +1. There's also mercury 1. Mercury 1 is diatomic. Each mercury in it has a +1 charge, so the total charge is +2. Okay, so it's one of the only diatomic metals that we have out there, mercury 1. Now, the three things you would want to know are the name, the formula, and the charge. Okay, those are the three important things to know for any polyatomic cation, or anion for that matter. Moving on to some of the anions, and there are many, many more. Nitrate has a formula of NO3 and a charge of -1. Nitrite has a formula of NO2 and a charge of -1. Sulfate has a charge of SO4, a formula of SO2 and a charge of -2. Carbonate has a formula of CO3, a charge of -2. And phosphate has a charge of PO4 and a charge of -3. It's a favorite of chemistry teachers. Now, these are all anions, and when we name them, our rules for naming anions are quite common. We name the anion. So, it's the cations that we have to worry about, and we already know how to work with that. If we have something with a known charge, something like, let's say, barium, its charge is always 2+, or something with a variable charge, like cobalt, which can have a charge of like +1 or +2 or something like that. Here we need Roman numerals in our name. Here we do not. So we apply that just like we would before with binary nomenclature. So this is cobalt. Cobalt is one of the elements that we don't always know the charge of, and there's nitrate. Each nitrate has a -1 charge, and there are two of them. So the total negative charge here is -2, which means cobalt must have a charge of +2. So this would be cobalt, parentheses 2, nitrate. K2SO4, potassium is one of those ones that we always know the charge of. It's always potassium, so it's always +1. I never need to specify it. SO4 is sulfate, so potassium sulfate is its name. And NH4 in parentheses, meaning I've got two groups of NH4. Those are called ammonium, as we saw up here. So our cation can be polyatomic, although it doesn't always have to be, but it can be. And then carbonate is the name of the anion. Tungsten 4 phosphate, W4+. Phosphate is PO4 3-. And so how do I make these two form a compound that has the normal charge? That would be W3 PO4 4. Okay. Zinc nitrate. Zinc is one of those ones that always has a charge of +2. Nitrate always has a charge of -1. So Zn and then NO3 2. Finally, mercury 1 chloride. Remember, mercury 1 is this, Hg2 2+. Okay, it's diatomic. And then chloride, Cl, is -1, so I'm going to need two of these. Oops, not Z. So Hg2Cl2. And that's how we go about naming these. So remember your rules for assigning Roman numerals to cations, and then just remember you're stating the name of the cation, possibly its charge if we don't always know it, and then the name of the anion. This is a much longer list, so please figure out what your teacher wants you to know and work with those. Flashcards are excellent.